Okay, there you go. I think we can start next couple of minutes. Everyone, hopefully you can see me okay. Okay, there you go. I think we can start next couple of minutes. Everyone, hopefully you can see me okay. Yeah, there you go. I think we can start. I'm sorry, I know you guys can hear the feedback. It's because I just started a stream and I could hear all of those playing in the background. Yeah, it's good. Everyone had a great day. Okay, I'm just allowing a few more people in. Um, okay, so let's get started. Thanks everyone for being part of this call. It's one of the it's a very good topic that we're gonna discuss. We did a similar topic probably in 2024, beginning of 2024, where small language models were definitely not many last year, and last year is a decade in AI because AI is running now. There's a lot of progress that we could see. Um, so let me share my screen and get started with the slides. And I have some poll for you guys who have joined the call. I know there are technical people, there are non-technical people here. So I just wanted to put a simple poll just to understand, the crowd and your background, because that would give me a good sense of, how to communicate if there is a topic that needs to be communicated. Um, Let me start that poll. Yeah.
How was your planning?
Yeah, so you all might have seen a poll in your chat. I am doing this for the first time, so I don't exactly this works, but yeah, I have asked few questions. There's just no one participated. I don't know if you could see a poll. Oh, is someone speaking? Okay, awesome. So let's get started. I'm about to share my screen. It took a while. I'm sorry. Yeah, there you go. I know you might have seen a lot of this too many tabs open here. Please excuse that. Uh, so we're going to discuss about small language models today. So small language models are something which are really smaller in the scale when compared with large language models. There are some jargons that we're going to use throughout this discussion because uh, there might be someone who doesn't know a lot of technical terms, but just added there so that you are familiar with these terms. So what is the parameters or what are model weights, model inference? So these are some of the vocabulary probably you should already know. And based on this, okay. So okay, poll is submitted. That's good. So these are some of the jargons that we probably need to remember to learn to understand the whatever we're gonna discuss today. I don't want to go through all of this. Maybe I'll just come back and talk to you, but I just can give you a quick overview of what parameters are. What are these parameters that we're discussing here? So these parameters are something that think about if think with an analogy. Just think of them to be some knobs that you turn to change the behavior of your or on a specific model behavior, or it could also be something like a knobs for a radio, you can think. And parameters really tells a lot about the size of a model. Big, we will see in this slide GPT, ChatGPT. I just put ChatGPT because ChatGPT is a product from OpenAI, but it's actually powered by a GPT model. But I had to put just ChatGPT because I know that's what most of them are using now, and they are also using that interchangeably, right? GPTs with ChatGPT. So that's the reason why I had to put ChatGPT. But if you're too technical, just excuse me. So if you see ChatGPT, or a model that is powered by ChatGPT, which is example, let's take GPT-3, it has 175 billion plus parameters. So it got billions of parameters, and it's really huge. So as I said, these parameters are basically something that are switches that have you change the model behavior. So more the parameters, there are too many behaviors or there are too much of information that your model learns. That's the reason why you will see bigger models are performs really they perform really well when compared with smaller models, because they got many parameters that can just grab all these patterns in language. So they have more knowledge, just like someone having a bigger brain and a smaller brain, right? Someone having way too many neurons, and some smaller brains may not have too many neurons. I'm just giving an example. It doesn't. I just want to just correlate this to things that we already know. So these are the parameters. So when I say small language model is something that considered to be somewhere 7 billion parameter, less than 7 billion or 7 billion. So that is where most of the small language models reside in that range. Some may go between 7 to 10 billion, but anything that is considered 7 billion or less than 7 billion parameters would consider to be a small language model. And as I said, ChatGPT is powered by a large language model. The GPT-4o and recent GPT-5, they all power ChatGPT. And ChatGPT product, these models from OpenAI are not the only large language models. We do have other large language models as well. These large language models are basically from Anthropic Cloud. There is DeepSeek, the Chinese counterpart releasing, open sourcing all of these large language models. Today, I think they released DeepSeek 3, the base model. Llama is from Meta. They also open source. ChatGPT or the models from ChatGPT and even Anthropic, they are closed source, so we can't host them by ourselves, but the other models are open source from DeepSeek and from Meta. So as these models are really huge, it requires a lot of resources to run. And how huge? So a regular Google search would probably consume 10 times less energy when compared with a large language model. So a large language model would require 10 times more resources when you're just doing a simple Google search. So they are really resource hungry. And Sam Altman recently he said they do have a lot of models that could be deployed, but they are short on compute. Even though they are investing billions of dollars building new data centers, they're still short of compute. So because it takes a lot of compute to host these models, a lot of energy. So all are residing on nuclear power plants. They are building nuclear power plants to get more energy to fuel AI. Um, so definitely, large language models are, but as we use more large language models, the resources for them would keep on increasing exponentially, and we are seeing that now. Um, so what is the benefit of the small language models? I mean, one of the benefits when compared with a large language model being uh, resource intensive, compute, uh, it could either be like a hosting and providing inference for any of the requests that are coming in. It will probably cost you more. The latencies are high. In order to generate one token, your large language model need to be hosted in memory, and it has to address your request. Privacy is a huge concern. I mean, yeah, ChatGPT is great, but we're putting a lot of information in there. So ChatGPT does know about everything about us. Today, Sam Altman was also talking about GPT-6 being more of memory intensive, or where they prioritize memory. It means ChatGPT would know everything about you, all of your personal details, so that definitely you could get very hyper personal answers. But who knows? Maybe if there's a cyber attack and all of the chats got released, then it's just not about your PII data, but it's also your behaviors, your interests, everything get leaked. So it's really a huge concern. Um, so customization is also pretty limited. When you're dealing with a huge model, the customization is really tough. I mean, any DevOps folks who are in this call, it's almost like when you want to update a monolithic application, it definitely, we don't know, we might get it wrong. We might break the application. A smaller one, yeah, it's easy to update. Same thing applies here. Um, so customization is something that we could do really well with a small language model. When compared with um, the performance, that is something that we already discussed, right? Because the large language model, since it has many parameters, it can grab more patterns in data. So it does give you better answers when compared with a small language model. But it doesn't mean that all small language models um, cannot achieve what a large language model could do. Large language models are more generalists, so they can you don't have to specifically train them in any specific task. Most of them are generalists, so you just send a request, you get an answer. So that's something that you could um, that you cannot achieve through a small language model. In a small language model, you could increase the performance of it by having proper fine tuning, or making sure that a specific action could be a small language model could be trained on specific actions, and then you get an answer. I mean, end of the day, that is what's going on, right? Everyone has ChatGPT. They use ChatGPT for a specific purpose. Maybe recruiters could be using it to create job descriptions. Maybe an engineer could be using it for writing code. There are a lot of small language models which are out there which are really incredible in coding, and every model that is released by these major players as of now, they also have a smaller language model that they release. So they do that through distillation. Distillation is a process like in which you're just narrowing it down, or distilling all of the knowledge, reasoning power. It could be anything that you want to, you're distilling the small language with, but you could distill those from a large language model, or you can fine tune it. So that's what we're going to look at. Like how can we make sure these small language models are still usable, and with all the benefits that they provide, how can we use in our workflows? So by fine tuning any small language model, and I think there's some few infographics that I'll attach that I have attached in the upcoming slides. So someone MJ, I think you do you have a question? You raise your hand.
Yes,
Yeah,
yes. Hi, I'm MJ and I do have a question. Can
go
you
ahead.
hear me?
Yeah, I can hear you, MJ. Go ahead.
Okay, yeah, no. And this might be a stupid question, but is there
Oh.
such thing as a medium language model?
Um, I mean, we don't call it a medium language model. We just say as a large and a small language model. And now the people are referring to nano scale language models, but they are language models which would be around 32 billion. We could consider them to be more of a medium, but we don't. We still say we still refer to them as large language models. Um, as a terminology, I never heard. If anyone heard, please let me know. But I never heard anyone saying like medium language models. There are some tiny language models that, I think everyone, Google just released a very small language model. It's like 270 million parameter model that we're gonna see today. So it's a very tiny language model, I can say. But there is no official terminology saying it's a medium or even tiny. But yeah, just it's a it's a word that out in the tech in the tech community. But yeah, hopefully I answered your question.
Yes, thank you.
Yep, thank you. Um, so yeah, I just give some analogies here, a scooter and a bus consuming more resources, just so that someone who's really not technical could probably understand. Joshua, you raise your hand.
Yes,
Go ahead.
Mari, I just have one query. In today's agenda, when you say fine tuning, yeah,
Yes,
are we going to use things like PyTorch or TensorFlow to, are you going to display one of those softwares?
absolutely. There you
Okay,
go.
thank you.
Yeah. So there's Unslots notebooks, which I'll make use of it, and also will be going through some of the fine tuning techniques as well. I'm sorry, I should have just put this agenda beforehand, but we'll be going through fine. The reason why I'm just referring to the small language models is like someone who is really new to even this. Small language models, or at least, this term called small language models. So that's the reason why I'm just giving you a bit of background, but definitely we'll go into doing like some fine tuning and all. We'll be talking about LoRa's too, LoRa's and QLoRa's and stuff like that. And also agentic workflows. This is a paper from NVIDIA. They say small language models are the future of agentic AI. I mean, I definitely agree with them. The reason is when we develop agentic workflows, we start with large language models, but it doesn't have to be large language models that, we are repeatedly using. We could start with a large language model, but eventually we can get into a small language model by collecting enough data, by using the inference output from a large language model could again be used to train a small language model specifically in certain task. What is an agent? What are these agentic workflows? I just want to refresh. Maybe if someone is really new to this agents. Agent is anything that is using LLMs ability to reason, LLM's ability to plan, and perform specific task for you. So imagine ChatGPT as of now. I think if anyone have already used agent mode in ChatGPT, that's well and good. If you haven't used agent mode, ChatGPT does. Um, uh, if ChatGPT need to act on your behalf, right? Maybe it has to go and book a ticket for you. So your ChatGPT would probably need details, or need tools to do that. Maybe tools to go out and look for flights. So that would be a browser that it might need to do something. So if you want to make use of LLMs to orchestrate, to automate certain tasks, these agents would make use of tool. So agent is nothing but is basically a wrapper around an LLM. It does use these tools to perform a specific action, and it also stores some important information in the memory. Like if you go into ChatGPT and ask it, hey, tell me about you based on all the chats we had, just tell me what you think about me, or tell me about me. It gives you everything that it learned about you because it is storing all of that in its memory. And ChatGPT also has an agent mode. Like I do use agent mode a lot. Like that in order to do research, I use agent mode in ChatGPT a lot. It does open a browser and goes in there. It does research, clicks buttons. So it's an amazing tool. I don't know if you guys want to explore and make use of it. I don't think it's in free version, but yeah, it's a huge um, uh, uh, feature and planning. So this is what an agent is. So how would you make um, so how would you make how can you use small language model for agentic workflows, right? Large language models, their ability for them to reason or plan is really great, but a small language model doesn't have that. So you are basically using fine tuning to make these small language models to perform a specific action way better than a large language model. and that can lead to cost savings and all. So I want to give you an example. It's an example, and I just gave you a screenshot of this because it's actually from a great video. Uh, I don't know if you all follow a YouTube channel called AI Engineer. It's a very good YouTube channel. If I think I would recommend everyone follow this. Uh, this is the channel. It's called AI Engineer channel. So I would recommend you all sign up for it or subscribe to it. They provide really great videos. So I got this use case from them. Like it's from OpenPipe. So OpenPipe actually provides this fine-tuning platform for you to make small language models beat large language models. So that is what they do. They provide the platform as a service where you can actually have a small language model. You can evaluate and slowly train that small language model and ultimately beat a large language model's ability to do that specific task, right? End of the day, you should define what task is it. So this agent has a task to read emails and answer questions. So if this is an agent to do a specific task, the tool here, the agent would have a tool. The tool is maybe access to Gmail, right? Because it has to answer the questions about your emails. So your agent or your LLM would need access to your tool. And it does go in there, and this is how the workflow is. So when you ask a question, hey, where is Shari's move to Portland targeted for? Then, this is the assistant. This is what's happening under the hood. It just go in there, it looks for keywords, Shari and Portland, and it looks for the time, and it goes in there and looks for, it does a tool call. So tool call is where it gets into the emails and with that access, with that authentication into Gmail. Because when you give access to email, you're just not opening up email publicly, right? Your tool would probably, your agent would probably authenticate to Gmail or whatever email server is it, and then get you a response. So that's what happening here. It's reading an email, and now you got a tool output where it actually retrieved that information. What's happening under the hood is RAG. If anyone not aware of RAG, just don't mind. It just it just goes in the emails. These emails are stored in some server. It just goes in there and matches, basically doing pattern matching to get you an answer. So this is where you get the answer. So this task could be done by LLMs like really fast. If you see this, this is one of the graphs that they show. They started off with a small language model, which is Qwen 2.5, 14 billion parameter model. I mean, yeah, we still consider this to be a small language model, right? It's 14 billion, it's not 7 billion, but still. So they if you see here, these are all the graphs for large language model. O3 is a large language model from OpenAI. O4 is also from them. Gemini is from Google. GPT 4.1 is actually from OpenAI. So you see their performance is pretty consistent, and they are able to answer most of the questions um, pretty consistently. And you could clearly see the difference here. As the models are, some small language models could not answer all of the responses straightforward, but I think O3 or O4 really did a great job because it's actually a pretty new model, and it has very good reasoning power. So that's really keeps this graph really high because O4 and O3 are really leading here. But if you see this graph, where this is a small language model, but they were able to improve the performance of this iteratively and eventually make it better than the OpenAI models in order to answer a specific question. So they were able to do that. And they were able to get almost 96% accuracy improvement by fine-tuning this model. And they've used reinforcement learning fine-tuning here to get this benefits. They did reinforcement learning fine-tuning, and this video is also all about like how to use reinforcement learning to make your agent really better. Um, so and cost savings. If you look at the cost savings for 1,000 runs, O3 was costing them $55. O4 was $7, whereas Qwen is costing them like 85 cents. Yeah, it might be a smaller amount, but as you scale 1,000 runs, maybe you're exposing this agent to your customers, and they all keep asking thousands and thousands of questions. That's at scale, you save a lot of money. So this is a great use case. I mean, definitely, we all use chat GPTs, but just by fine-tuning an SLM, you can just get better benefits than a um, than a large language model. So yeah, definitely. Last year, um, it's a huge update. These were some of the models that in 2024 we got to see. It's a great visual from Data Science Dojo. I think I put a reference here as well. But yeah, they just are referring to how different small language models, which were like really leading. They missed Quen model because I don't know, because of that being a Chinese model, I'm not sure, but they include OpenELM. OpenELM is actually from Apple. If you see the Apple Intelligence as of now, most of your Apple phones with Apple Intelligence, they have a 3 billion parameter model on your phone running. It's literally a model running on your phone. I don't know how many of you are aware of like Google has 14 plus versions, 14, 15. After 15, all of the versions, which has the Bionic chip, they have a small language model, which is almost 3 billion parameter model that they're working on. And OpenELM is their open source project that they have open sourced and published a research paper on this to answer some basic questions, whatnot. It's not that great. I mean, I've used it because it's being a very small language model, right? Yeah, you can't expect it to do like really great things like how ChatGPT would do. Um, what about 2025? So 2025, it's been really busy. I mean, yes, every model, like there's so many models coming out every month. And I've just put this list from ChatGPT. I've used agent mode in ChatGPT to do all this research. But yeah, if you see here, a Quen 3, it's from Alibaba. They are and Quen 3 and Quen itself is really providing great models. zero point 0.6 billion to 32 billion parameter, and there's a very great improvements that we see in terms of reasoning and coding. Gemma is a 3 and E2B is actually a model from Gemini from Google. They have built this model to be deployed on Android phones. They come up with a very different architecture. I don't know if you all want to read about this. You can read. It's a great it's a very different architecture that they've came up with, where you could actually combine and match different blocks of information. So they call it mat former architecture. It's a bit more technical. I can leave this paper here or this blog. You can just review that and read about it. I feel like this is going to power their next gen Gemini Nano that would come end of this year, where every phone would be coming up with that, and all developers could actually use that on-device model to do some AI. So I'm really, really excited about this because when you can do things on device, it means you're not sending your personal data anywhere else. It just all resides on your phone. So that's the true meaning of privacy. So E3 and E2B, E4B. So E2B stands for like 2 billion. E4B is a 4 billion parameter model. So you can actually with Matt Farmer architecture, you can actually create your own different variations of this. And Gemma 3, 270 million. I'm not talking about billion parameter model. This just came out like in August, like a few weeks ago. Not even a few weeks, maybe a week ago. So it just 270 million parameter model. It's very, very small. I mean, it can actually fit in in our on the laptop as well. I mean, I could actually run that um, in my uh, Yep, there you go. So there is something called Olama. I don't know if you guys, if anyone uses Olama, but it's a very straightforward tool that you can install and use. It's a Quen. So this is the model which I'm running, which is Olama Run Gemma 3 270 million parameter model. It's pretty straightforward. I ask few questions like sing a rap song about rabbit, or maybe some small questions. So it's a very very lightweight model and small model. So you could all run this model. If you see the output is not that great, I mean it is definitely good, but it cannot be as equivalent to as ChatGPT. Um, you know, um, maybe I'm just giving a rap song, but these could be really good with coding and all. But yeah, it's just these models are very good with instruction following. The reason why these are developed is to follow some instructions on edge. Maybe tomorrow you get to get some output in JSON, and you want that to be strictly JSON in structured format, you could use this model. Or you want to do a simple thing like to forward maybe you need to generate some content in certain way, you could use this model. But this cannot be used like ChatGPT because the cognition is not great for these models. And it's being significantly small model. And so anyone can use Olama. So if you all are interested in just getting this small models up and running, just make sure that you have enough resources. Yeah, things might sound maybe a 4 billion parameter might sound not a lot, but 4 billion would definitely, or maybe a 5 billion would need at least 10 GB or 11 GB of RAM. So it all depends on your machine. If you have MacBook, that's great. But if you're using Windows machine, just account for that. If it is 7 billion, you at least need 15 or 16 GB in memory because these models would be stored in memory to give you an answer. So this is a very recent model, 5.4. It's from Microsoft. It's 3.8 billion. It is really doing great in terms of math and coding and reasoning. Coding, reasoning, it's very easy domain to make a model very efficient, and it's very easy because coding and math, these both are self-verifiable domains. It's like you can just in math, if you know if a model is actually doing right math or wrong, you have thousands of mathematical examples in so many textbooks, where you know already the output of it, right? So it can self-play. It can just go spit out random tokens of mathematics and see if it can conclude that equation. In that way, it can actually learn math. Coding as well. If you ask it a task, it can just go, just just emit a lot of these tokens, and it does a self play, generating and learning patterns, or learning that it does exploitation or exploitation in RL. That is how RL is really booming now, because reinforcement learning is making these models reason really well, and even a smaller model could reason as per the reasoning power of small language models are also increasing a lot with this reinforcement learning. Um, there is Gawk3, that's from Twitter, and we don't know the model size, but they seem to be, and it's more closed source. Grok is pretty. There are very few models, and I don't use Grok honestly. I use ChatGPT a lot. I use Quen models for multimodal models and all. Um, DeepSeek R1 is they also came up with smaller models. So DeepSeek is not just a huge big model, but they also have distilled versions. They call it as distilled because these models are being distilled from a bigger model. So how they do that is a bigger model would be a teacher model, the actual bigger model with you know billions and trillions of parameters that would generate outputs that would be used to generate a smaller model. So that's how you're distilling the knowledge from a bigger model to a smaller model. So they call it as distilled models. And they are 1.5 billion, 7 billion, and 8 billion. These are some models that they have already released last year. Um, and they even beat like GPT-4o and Cloud 3.5. That's the crazy part. They are, I mean, not in every task, but in certain tasks they would. Um, And multimodal, we can't forget multimodal. So because multimodality is definitely a huge application. So where you get your models analyze videos or images, um, you know, uh, Quen 2.5 VL, it does really great with videos, long range videos, videos which are hour long. They came up with new tokenization. They are just using 3D, three dimension embeddings. They're creating tubelets to do that. So they're actually using two different frames, flattening it out, and then using tubelets to train this model to analyze videos. So it's not that I know video could be a repetition of frames, maybe different frames would make a video, but they're not doing that. They're actually feeding a video because a small frame change could define an action, something that would have happened. So they are using a altogether different tokenization methods to train these models on videos. It's really effective. And these coming in 2 billion, 7 billion, 32 billion parameters is really great. MedGemma is also multimodal. Polygemma is actually from Gemini. Um, it's used in to do a lot of OCR document retrievals. Segmentation. These are some things that you could do. Gemma 3N is also, I don't know why. Yeah, only the 5 billion and 8 billion, these are multimodal. So at least we need 4 billion parameter models to be multimodal. So any model that is below 4 billion parameters and that being multimodal, it's not possible. We at least need 4 billion as of now. I mean, it might change pretty soon. But yeah, as of now, this is the one of the some of the metrics that we probably need to look at. So anything that is below 4 billion. I know there's 3 billion, which definitely have to fact check that. But it might be because it's just doing OCR, right? So it's already specific. It's only doing a specific task. So that could probably be the reason. Um, so yeah, I think these are some multimodal SLMs. So how can you fine tune, right? This is the whole purpose of this call is like, how do you make these small language models uh, good at certain tasks? So that is something that we're going to look at here. Before that, um, if anyone has any questions, we could take them. Oh yeah, I'm sorry, I'm not running in full. Can you guys see my screen still? Can you all see my screen? Okay.
Yes, we can.
Yes, yes. Okay. I mean, you could see the full screen, right? Okay. That's what I want to make sure. Okay. I see some questions from Maheshwar is asking, is there any cost difference for TPMs in LLMs and SLMs? That. Yeah, I just have to mute someone. Please do mute yourself if so that we don't get any disturbance. But yeah, thanks for that. Is there any cost difference for TPMs in LLMs and SLMs? TPM. What is a TPM, Maheshwar? And I'm sorry, I didn't get what is a TPM. If you can drop, or maybe you can speak out, or anything works. What was the pass you mentioned that has run through type?
Tokens per minute.
I'm sorry.
Tokens per minute.
Okay, I'm sorry. I'm sorry. Yeah, is there any cost difference for tokens per minute? So tokens per minute is up to the inference cycle, right? So how would you increase number of tokens per minute? That is up to how fast, how efficient is your KV caching, right? How efficient, and also the chip that is running is also makes a lot of difference, right? You could actually make an SLM generate more tokens than LLM because definitely the speed, the latency is really low. So when you say the cost difference for tokens per minute, the cost end of the day would be significantly lower for SLMs when compared with an LLM because why it costs more is LLMs definitely you need bigger machines, more energy, electricity, whereas SLM would need a smaller machines. But you could beat LLMs if they are deployed on maybe some ASIC like etched or even some companies who actually provide ASICs, which are transformer based, they do have very high inference, like 300, 400 tokens per second. So it all depends on where you're deploying it, but end of the day, the cost for SLM is always lower when compared with an LLM.
Okay. Yeah. One more question I have. If we take in a broader sense, for particular task, we have to fine tune a single elements. I mean to say, if you have a multiple tasks, then we have to consider multiple SLMs. In that
Mm-hmm.
case, one LLM can answer
Oh.
all the questions. So
Mm-hmm.
we can consider only one LLM and get the answers from it. The time and the GPUs for
Yeah,
that,
got it.
and so whatever cost for that, right? That will be a
Yes.
single cost that
Yes.
maybe consider it as $100. For if we have 100 tasks
Yes.
and single SLM per task, if you are fine tuning,
Mm-hmm.
so $1 for a single SLM.
Yes.
Then
Yes.
if you have 100 tasks, that will be $100 for all the SLMs, right? So the cost is same. So if the tasks are increasing, then we have to increase our SLMs also. So
No, it doesn't have to be like that. I'll tell you why. So you're saying 100 tasks, right? And you're only isolating SLM to limit only 100 tasks, and you're also isolating per task per SLM. you could even start that way, but end of the day, again, you can optimize it and you can have one SLM handle, like probably eventually with a lot of iterations, you can even have one SLM handle all 100 tasks.
Okay.
So you don't even have to say, oh, one task per SLM. SLM is not, I mean, unless you're using like 270 million parameter model, like a Gemma model, which is like,
Yeah.
it can handle too many things. But with proper fine tuning, we could do, and we should also know the task at hand, right? Because we are making these models domain experts, right? We're just giving them proper data and we are specifically fine tuning them to do good to either being a tool call. Tool call is just going out and sending an email out when something happens, when going and doing a function calling. These are all tool calls that it could do. So if it could do a great cool tool call job with high accuracy, yeah, then we could, and also it could also include maybe generating something in a specific style. We can have all these tasks could again be imbibed into one small SLM, and it can do way better than an LLM too. So
Yeah.
that's
I know.
a trade-off that we could have.
I know that's a stupid question. Sorry.
No, it's
It's
not.
not a
It's not.
tool.
Now, no question is stupid question. Definitely,
It's
you're
not
all
a
alone.
tool. I know it's a large language model, but
Yes,
just in case I ask.
absolutely, absolutely. No, no, no problem.
Yeah. Yeah.
What was the? I mean, hopefully, I'm just moving on to Singh. He's asking what was the pass you mentioned. It is open pipe. It's called open pipe. I can put it here. So it's open source. They also have a lot of, but it's a good thing that you want. If you want to just go on play around with LLMs, I'm sorry, reinforcement learning and making small SLMs fine tuned, you could do that. Is it okay? Yeah, I can do this. I present the slide deck. I found the local open source to waste my time efforts on simple tasks like converting, transforming JSON to CSV, Gemini. Um, oh yeah. See, the thing is, you're just doing a conversion, transforming JSON to CSV. I mean, first of all, data transformation is something that you could still, it has to be deterministic. It's a deterministic task. So you definitely can use a script to do that. JSON to CSV, you don't even need to have an SLM or LLM to do that. Yeah, there are folks using it to do data transformations, but data transformations could not be, as LLMs and SLMs could not be used for data transformation. You could write a Python code and do it at scale, maybe have your data warehouse. I don't know if I might got it wrong or yeah, maybe that's one of the things which I wanted to say, DJ. And any suggestion? I'm hoping to learn better tuning to get better results. Yeah, you don't have to tune, by the way. Please don't you do any tune unless you're doing like JSON, because you're doing a straightforward JSON to CSV conversion. So that would definitely, you don't need a LLM at all, because these are all probabilistic machines. You don't have to use a probabilistic machine to do something more deterministic, right? If it just messed up a simple column, then probably your CSV would not be in order. Maybe it might break your downstream task or downstream processes. So it's not a great use case to even like use LLMs or SLM. Just write a simple Python data transformation functional code. Um, yeah. So I mean, I could probably pause. Like, I'll just take one question, last question. So, how is an SLM fine tune on a use case different from the GPTs available on ChatGPT for specific use case, or are they same? Is fine tune on a use case different from the GPTs available? Oh, come on, GPTs available on ChatGPT. Those are all basically those are doing RAG. Okay, they're still powering by the large language model, but what you're doing is you're just adding more context by uploading files. I mean, GPTs being I mean, these custom GPTs, they didn't picked up as people thought it would have picked up. They wanted to have it as an app store of different custom GPTs, but custom GPTs are just LLMs with knowledge base. You're just uploading some files and customizing it to do something. Um, so yeah, so they are different. So SLM fine tuned on specific use case. It's you're basically saving a lot of money around the inferencing. You're also getting low latencies. You're getting great performance by fine tuning them, right? That's one of the major things. In custom GPTs in ChatGPT is still using an LLM, so it's not an SLM at all. But when you compare the performance, like one is doing RAG, the other one is actually a model itself is learned. It changed that behavior with fine tuning. Oh, DJ says, but the point of AI is any task autonomously, right? Yeah, no. I mean, I don't think every task would be done autonomously with AI. I mean, I work with AI every day. It's AI agents are also not that reliable. That's the reason why we need to do evaluations, which will be a very important thing, which I'm gonna talk to you in the next few slides. Yeah, so fine tuning, there is something called a full fine tuning. Full fine tuning is where you're updating all of the model weights. It's a high resource deal. Like you need to have a lot of resources to fine tune, to fully fine tune your model. And if it is a smaller model, yeah, you could do it. It's because there's few parameters. But full fine tuning of a huge big model is really it's. I mean, I don't think it's. And no one will even attempt. Even for small language models, we don't do full fine tuning because it's full fine tuning is like changing all of the model parameters and all of the model weights. That might sometimes lead to you know forgetting that these models really have once they are fine-tuned fully. Risk of overfitting is definitely there. There's a lot of it can't adapt to new tasks. So there are a lot of issues with full fine-tuning. So we're not going to do this. Like, I mean, they're not like industry is not doing this yet, very less. Oh, this is very important. LoRa's, it might be a bit more technical if you are not into understanding under the hood what's going on with these models. Um, it would be a it would not be a maybe you might get confused or you cannot follow along with this. So I just wanted to I will put it out there and how it works. So usually LoRa's are something that you are basically adding new weights to your model. These are separate weights that you add. Imagine adding a different matrix within your attention layer or even your MMLP layers. And then you are basically you firstly create a subset of tasks. So if you want your LoRa's or your models to be maybe doing creative writing, right? You want your models to do a creative writing in a specific domain, maybe creative writing about history. That is one of the use case that you want to fine tune your small language models, and ChatGPT is already doing great. Now you ask ChatGPT to generate like maybe 100 or 1,000 of these different creative writing in history. You get all these outputs, which are 1,000 of them. Now you store those 1,000 outputs in maybe some data storage, maybe in databases or S3 buckets. Now you use that data to fine tune your small language model. But how do you do that with LoRa's? It's basically you're adding new weights. Weights are nothing but blob of numbers. And then what you do is you train the model by using the data that you have. We're gonna see this now today in this notebook how this is all done. Um, so, and it is also, so LoRa has something called low rank adapters, but if you really want this to be even more compute optimized, you could go with 4-bit quantized model. Yeah, 4-bit quantized, maybe it doesn't sound, maybe if you are not familiar with quantization, please don't mind. Quantization is basically a technique to reduce the model size. So how are we reducing the model size? So if you know, model is basically a blob of numbers, right? These weights, these knobs that you turn around. So if usually these are like float 32, it's mean like 0 point all the way till 32 is a huge number that you probably need to multiply or operate. So you are basically truncating that and making it shorter to just 4 bits. So then you're not dealing with like huge model. Rather, you're just looking for like a truncated small number. So now it is easy for you to do fine tuning. You could do operations on it. You can do inferencing. You can host or run the model locally in your laptop if needed, because you could even run like a 50 GB or I'm sorry, a 32 billion parameter model or even 100 billion parameter model on your laptop by quantizing. So you're reducing the weights complexity to being just 0.4 bits. That's it. And that's called quantized LoRa. It's just you're reducing memory there. So these are the small weights that get added additional to the model. So you're not changing the actual model, but you're introducing some numbers into this model, and then you are training that model and then back propagating to see the accuracy and all of those that we're going to see pretty soon. There are also other things that you could do with small language models apart from loaders. It's instruction tuning. So instruction tuning is where you create, just like how we did previously, create a task specific data set, and then you instruction tune that specific thing. So there are different strategies to do that. I just covered DPO here, which is direct prefer optimization. It's just you're putting a question and answer. You're telling, hey, this is what that I would need, and this is something which I don't need. Your reply should be this way, and your reply shouldn't be this way. So this is the thing that they use to fine tune ChatGPT already. All the ChatGPT is actually fine tuned. I don't know if anyone of you are, fine tuning actually makes a model, right? You can't go and ask ChatGPT to give you a recipe to make like bioweapon, because it's already fine tuned to never answer those questions. So you so that's the reason why you aligning the behavior of your model with this fine tuning, right? Instruction tuning. RLHF is not a scalable thing. ChatGPT was actually built like the GPT-3 model is actually GPT-3 is because of this human feedback, reinforcement learning with human feedback. Humans, if any process involves humans, not scalable. But ChatGPT was trained with this, where they use reinforcement learning, and the feedback given was by human. So that's the reason why ChatGPT is able to generate outputs which are pretty uh, uh, outputs favorable to humans for us to digest and understand the language, right? That's something that was done with this. So every base model out there that is trained on huge corpus of data, and once you get and you ask it to generate an output, it just it just throws like different words everywhere. Like it doesn't even talk in English. Probably it will even include math equations between English immediately after training. Post training, that is how it is. But what they do is they do a post training processing in which once the bot is trained, then these things come where it is a DPO, it could be RLHF, it could be instruction fine tuning. These are all something that could be also applied for an LLM. It could also be applied for an SLM. So it just I'm touch basing both of the concepts that is actually applied for both LLMs and SLMs, and they definitely align. And you can have a small language model to do a specific task by creating a data set and then just training that through multiple loops. So that's something that you could probably do with this, and it's just the policy updates that happen. So when you're using reinforcement learning, the policy updates here is the model itself. The model weights it gets updated. That is what the policy update is, if someone is coming from reinforcement learning background. Because reinforcement learning in robotics is different than reinforcement learning in language models. We have covered this few sessions ago. So reinforcement learning is way different in language models. I mean, it's the same concept. There's an action space. There's an actor. There's a different exploration, exploitation. All these things happen, but the policy when you're dealing with any language model or a small language model is the model itself. So I don't want to go more into the reinforcement learning fine tuning here, but yeah. Um, Now let's go ahead and just play around with some of these notebooks. I mean, Onslaught is doing a great job by producing these notebooks. Um, so these notebooks are, let me just take you to this. Yeah. Yeah. So if you see this is just a Gemma 3 270 million parameter model. I mean, I could have, I mean, I'm putting this link to the collab uh, in the chat. So if anyone wants to just follow along, just execute it. These are great notebooks. They get executed. You usually don't run into any issues, but um, yeah. So so what is Unsloth? Unsloth is basically this community or a company who releases these fine-tuning notebooks as soon as a model is released. They have a lot of algorithms that they have built, like dynamic uh, 2.0 quants. It's a quantization method, just like how we discussed about the 4-bit quantization. It's one of the algorithm that they came up with that really makes the fine tuning really fast, even for very big models. So they do provide all of these as part of their Unsloth notebooks. So so I can share these notebooks to you guys. There are a lot of hundreds and hundreds of these notebooks that you can use to learn fine tuning. And so this is for five, this is for Gemma 4 billion parameter model. And they have different modalities that they support. This is for text and this is for vision. And this is the 270 million parameter model that we're going to see today. And you see all these notebooks even for multimodal models, this text to speech notebooks. So these are all just meant for fine tuning. GRPO, the other notebooks. So feel free to, you know, work on it. And you can also see there is a notebook here called tool calling. So they are improving a model on tool calling, how to make the model very efficient to call a specific tool. Yeah, it might not sound a huge task to do that, but tool calling is beautiful, because if a model could do a right tool call at right moment, it means it can be very beneficial to anyone to do. I mean, yeah, you could write a script to do to do this orchestration of maybe calling an API and everything, but this interaction where you are talking to an agent or agent autonomously taking some actions on behalf of you, would probably need a very accurate tool call. It can't just go and make a payment for your flight before even researching flights, right? That would be a disaster. So it should know exactly how to make tool call and everything. So this is one of the notebooks that they have given to perform this. I can just share this notebook, but what all we have to today we're going to see this notebook where you have we are using LoRa to fine tune this model. And I've already shared that with you guys. So we can just go and execute it. I can just go through this really quick. It's a very simple model. What they're doing here is they're fine-tuning Gemma 3 270 million parameter model to play chess, like to predict the next move in chess. So they have created the data set and everything, and they just run through multiple loops, and I'll show you exactly like how these things are working together. Abel, I see you raise your hand. Any question that you have? You can speak out.
Can you hear me now? Yeah.
Yes, I can hear you.
So did you say that this could add tool usage to SLMs and LLMs?
Mostly SLMs, not LLMs. Because I mean they have probably given this for, yeah, it's just 1.5 billion parameter model. So they can change the behavior to do a specific tool call.
Okay. Thank
Yeah.
you.
Yeah. So so yeah, you see this is how the tool call workflow is. Like, given an application, uh, you know, maybe you have this application that can go ahead and call series of SQLs to do something. All these SQLs to get different data, and now you want to go ahead and maybe call a SQL statement that can get you results for a specific demographic, or maybe a specific state. You could probably do that by chatting with this. An LLM decides what SQL to call. You don't use LLMs to create SQLs, and please don't do that. Anyone who are using LLMs to do SQL generation, please don't do it, because LLMs are not great at generating SQL. Yeah, ChatGPT could be great. You probably might have seen um, where ChatGPT provide generated SQL, which is really complicated, maybe 80% of the times out of 100, or maybe it really worked for you, right? Because it's 80% chance, right? It would probably work. But they might fail even after you prompt them, when you say, hey, just don't reply this way or just use this SQL, that only works 70 or 80% of the time. It might fail 20% of the time. So your SQL would not, your generation would not always be the right move. So always do a tool call. So you already have predefined SQLs and now you're doing a tool call to the SQLs to get you an answer, right? That is more it's more secure because now you have an LLM that generates a SQL which does go and delete something, or it is really expensive to your database, which is doing really complicated joins that just burning your credits. Now, it can give you SQL, it's magic, but still, it's very undeterministic. So you can't couple both of them. So you basically need to do with tool call. When you increase the accuracy of it, it does know which SQL to be called at which situation, at what kind of parameters that it has to collect to do that tool call. So yeah, that's how the tool call. That's the reason why I say tool call is really important. I mean, we don't want these LLMs to be really good with doing a lot of producing a lot of we don't want to rely on these probabilistic machines to generate something that can impact your systems. Don't give control. If you want to give control to these LLMs about maybe for an agent, if in case it has writing code or it is just doing some operations, create an isolated environment in Docker or something like that, so that you don't. Or there are some projects called E2B that you can use, E2B sandboxes that you can use to do that, right? So don't give control over to them. So tool calling is really significantly, it has a lot of importance and weightage if whoever is trying to do, fine tuning. So that would be most of the use cases that people would probably use fine tuning to improve the tool call accuracy, maybe from 80% to 95 or 98% accuracy, right? So let's go ahead with this specific notebook. So as of now, you see this notebook, all of the Unsloth notebooks, they download some of the packages and they patch it up. So they patch it with their own algorithm that they have. And what they do is, they get this, bits and bytes, accelerate, xformat. These are all, and PEFT. PEFT is parameter efficient fine tuning module. The LoRa's that I was talking about previously, those are all packaged with this and with this TRL, Triton. There's a kernel, there's CUDA kernels in PyTorch. So we're going to use all this. And will these are some of the packages that are used to fine tune the model. And you could also see here we're using Unsloth because Unsloth uh, develops these kernels that can really makes fine tuning really fast. That's what they are known for. And you see here, we're using from Unsloth, we're using fast model, which actually has a lot of models inbuilt. And you're basically using, and all of them are 4-bit dynamic quants. It's not 4-bit quantization. They're saying it's dynamic quant, so it's using their own algorithm to make it more accurate. And also, I mean, they're making the fine tuning efficient with less compute. So that's a huge deal. And there are other popular models. These are all different models that are already available. There's Llama models, which they have, which are all 4-bit dynamic cons that they've already pre-baked and pre-built that you can use to fine tune for any specific task. And you see, but the model that we are going to do that is 270 million parameter model. It says IT is an instruct model that we're going to use. And here you're just choosing a specific context length. So context length is it's a very good term that I've actually added in the jargons. It's the limit in which a model could only grab or only remember certain things, right? A maximum number of words or tokens the model can remember at once. That is what a context length is. It's really a very important thing that you probably need to understand. And I think as soon as so as of now, what we're using is we're using this max sequence length. We are just putting this as false because I think they are already using their own 4-bit dynamic quant, so that's not needed. So they have put all of these loaded 4-bit or loaded 8-bit as false, and full fine tuning is also false because we're not going to do full fine tuning. As I said previously, full fine tuning is really compute intensive, and also it might lead to a lot of unexpected outputs too, because it might forget things that you already learned previously. So that's already a recorded issue. So I mean, if someone wants to visualize like LoRa's and everything, I can just show you simple diagrams on how this looks like. I mean, if you maybe I need to take you back to matrices. Uh, rank of a matrix, you need to define or even derive the rank of a specific matrix to create a low rank matrices that can be added parallelly. So these are the extra weights that we are adding. These are our pre-trained weights. So if it is a small language model, the large language model, these weights are frozen. We are adding new weights. And now what we're doing is we are just using we are only training um, uh, we are doing fine tuning on specific data set as we previously learned, right? So these weights would contribute to that behavior. So end of the day, these weights that you add would change the behavior of your model. You're not changing the weights of existing model. You're just introducing new weights and then you're fine tuning that. And then as soon as you know that your accuracy is going up, and how would you know that, right? That is what part of the evaluations is, right? Evaluations are really important. This is not you're not writing software. You're not writing a Java code or Python code that can just return the same API response whenever you do a API call. We're dealing with undeterministic things, probabilistic missions. So evals are really important. So, and someone coming from software engineering space, this is something that you're going to do later. Like this is all something that we all will be doing. We all will be evolved to be AI engineers working with this undeterministic things, which is really takes a lot of effort. Yeah, maybe AI is writing code, but it cannot do all this. It cannot do all of this. I mean, even if it could do, we still need humans to be there and check and validate and measure and create guardrails. There's so many things that we all need to be doing. So anyone out there really insecure that, oh, this can take my job, please don't get that in your mind. We all be evolved. Every software engineer will be evolved to be building software 3.0, or I don't know what number I should call them, but this software is very, very undeterministic and we don't know what would be the output. So we get to gauge it. So we need to I give you 100 inputs, and out of 100, how many is something which I like? Like out of 100 creative writing in history fine tune that I did, I give you 100 examples or 100 questions. Now you generate it. Now I'll go and judge if that output is up on par with what I am expecting or not, right? Um, so we're going to do that with evals, and that is how you know that the model is improving. The model is improving and learning new skills. And the beauty of this is, let's say you have 4 or 5 different tasks, right? Maybe you have 100 tasks, and you fine tune this SLM with 100 different tasks. And these weights that you add could be task dependent. So if you want the model, the same thing is happening in your iPhone, by the way, right? Your iPhone, the new iPhones, which have Apple intelligence in them, which has 3 billion parameter model, it has LoRa's. So if you want a iMessage to be sent and iMessage need to be typed in certain way, there is a LoRa for that. So your base model weights are not changed, but this additional LoRa's are added. Those are already pre-trained. Those are added to your main weights. And then now your behavior of the model changed. Now it is really good with writing iMessages. There's one model to make emojis. Then you have this new weights that you add. So you can do this hot swapping, right? That is something that you could do with this LLMs with using VLMs and all of them, right? So you could change the behavior of this model by swapping this LoRa. So you add new LoRa, and now this LoRa was built to get some skill, to learn some skill. Now you're just changing that dynamically, and you're changing the behavior of your LLM. So that's the beauty of this LoRa's and QLoRa's that you can take advantage of. And yeah, I think this is done. So yeah, you see here, right? You get this PEFT model. So you're introducing this weights. You come up with R, which is the rank of the matrix, to be, they usually suggest 8, 16, 32, 64, 128. So here they're usually just using 128. And these are all target modules. So these are all something that actually does in the embedding space, in the latent space, where you have these um, projections of all of these. And first thing is you create the alpha value here based on this um, specific updates that you're gonna use for this to yeah, I mean, I don't want to go too technical, but yeah, these are some parameters that can affect your training process. And then there's also a lower dropout. You have some bias. You use like do you use any gradient checkpointing? They mentioned as onslaught. And they also have this, other configurations that you can basically uh, use or change the behavior of this. Um, so based on this, this you treat to be as a additional weights that we're adding to this, so that you can now create that you can add this LoRa to the model, and you are also mentioning where you are targeting this in your overall model architecture. I mean, yeah, when you say KVO, I don't want to again go back and explain about transformer architecture and what is K, what is Q, those values, but just understand that these are some configurations that can change your PEFT, uh, or configurations that can define this weights that we're going to add here, right? This A and B matrices that we're adding here. Yeah, I do see yeah, I'll just give a brief pause here, just get back to you guys. There's a small, someone raised the hand. Peter, can you ask your question?
Yeah, can you hear me?
Yes, I can hear you.
Yeah, so I was just wanting to compare this to other kinds of transfer learning I've done in the past. So before, like I've used for computer vision, this was like AlexNet, and then do transfer learning with AlexNet, and then
Peter,
like
I'm sorry for interrupting you, but I can't hear you. I have really difficult time understanding what you're saying.
um,
Do you have any earphones on or something like that? I could just a bit more muffled your sound. Can you type it? Can you type it down if you don't mind?
Is this microphone any
Oh,
better?
oh yeah, this is amazing. Yeah, go ahead.
Okay, yeah. Um, so I was just wondering, I've done like transfer learning with computer vision where I take like AlexNet
Mm-hmm.
or ResNet 50,
Mm-hmm.
and then I'll add like MLP on top
Mm-hmm. Mm-hmm.
and do the fine tuning that way.
Yes.
But that in that case,
Mm-hmm.
the the ResNet, the weights are frozen.
Yes.
Um, but I'm doing it kind of like in series, where I have the new weights come downstream from the output of ResNet. Whereas in that diagram that you were just looking at, it looks like the way that you do fine tuning with large language models, you do it kind of in parallel, where
Yes.
you create these new weights um, for every QKV. Um, uh, and I assume that you also do that. Um, for each attention head and then for each attention block as well.
Mm-hmm. Mm-hmm. I mean, yes, we do that for, yeah, different attention heads as well. All of the, I mean, if 32, then 32, we have to do it. Yeah.
Okay, great. Yeah, I just wanted to
Yes.
clarify that.
Yeah, but
Um,
go ahead.
and then I was wondering, I know you don't want to get too technical, but is there any like intuition that you can give me as to why lowering the rank um, is kind of like acceptable and why you don't?
I mean, it's just around, rank. It's just that it all depends on like, different parameters. It's just a parameter you can play around with.
I saw
Okay.
no, but I didn't say any minutes. No, I thought. Oh, my minutes saw that. I made last week, and I spoke downstairs. Oh.
I'm sorry, there's some issue. Um, so basically, so yeah, the rank, the reason why, I mean, you're asking why the rank is lower, or why the rank, what is the significance of this rank, right? Why do we, and how do you decide that? So it's just random parameter that you use to, um, just to add weights of a certain dimension, and then and then based on that, you just see if that is something that your model could converge on or not. So just
Okay.
like any other parameters, how you add, it's just that. So we're not. And also, when you do this rank, you're not just updating the weights, and you're also the computation. If you have lower rank, the computation overhead is also lower, right? That's also something
Right.
you can, yeah, you have that perk too. So you are balancing out both, compute and this. When you have lower rank, then yeah, you're not doing too many crazy matrices, but still, it's a when you're adding it parallel, and it's and then look for this measure of conversions when it is converging and what, and balancing that with compute. So that's what it is. Yeah. Hopefully I answered your question.
Yes. Thank you
Yeah.
very much.
Thanks a lot, Peter. So yeah, this is something that's done here. So now we got this, and data preparation. I said this is a very important thing, because um, the if someone is using LLMs now already, and you're doing it for certain use case, maybe you have this LLM that can do a chatbot, um, or it can, you see, when you develop an AI agent, or maybe anything that maybe a workflow or an agent. Yeah, there's a lot of people say, hey, it's a workflow, it's not an agent. But yeah, it could be a workflow, it could be an agent, or it could be a combination of it, right? You have a task at hand, you know what is an output. All you do is first collect that input and output from your models, from your large language model, whatever large language model you're using, collect that. How would you collect it? There's a lot of things that you could do. You can use different tools. There is also a tool called LangFuse that you can use to collect that information. And then in LangFuse, you got data sets, and data sets, you can actually create a data set and collect all of those, and then use this to later on fine tune a model, right? These are some tools which are already available outside, called LangFuse, or maybe Lam, or even if you just want to write a script to just tap into that and store that in database, you could do that too. But yeah, that is a golden data, because now you can use that data to fine tune the model, a small language model. So if you see here, this is we got this data, and this data has a multi-turn conversation. You're using these different functions to get that specific data, and then using this chat template. You're just trying to have a specific tokenizer and a model. You're just defining that as a um, as a configuration for this tokenizer, and then you're importing the data set. And this data set has all of this chess instruct. It got how many 10,000 examples, and then you're just splitting it up, traditional training process, where you split it up into different train and test data sets, and then you're just converting that to uh, chat ML to correct certain format. It could be because when you're trying to train your model, you're training that still to be a chatbot, right? That's the reason why the data format is as with different persona, like system, user, and assistant, so that these personas are something that you can carry along, because you definitely want your model to still behave like a chatbot. So yeah, you have that here. And then if you want to look at data set, there you go. This is your data set. And formatting certain prompt function that we're doing here. We got some conversations, and you do get this text with various parameters, and then you see how chat. I mean, what chat template did is just to create that as a multi-turn question and answer data that we're going to use to fine tune our model. And now we're training the model, and we're doing 60 steps to speed things up. And he's saying that you can even set that how many epochs you're going to run. So it's a traditional training process that if you have previously not done any training, please go ahead and just start clicking these buttons and understand every part of it. But yeah, this would be a great way for you to train a simple model to do, maybe to play chess. And yeah, and they're just using it for a specific. And the reason why I'm using this is because it takes really less time to do the training because it's just 270 million parameter model. So it's a perfect example. Um, and once that is done, then comes, these are, we are basically, once you train on completions, it's just, to train on the outputs and to basically assess the accuracy of this complete system. And you're just decoding that with various input IDs and and there you go. You're just printing a masked output of it just to see only the answer is present or not. This is all we're doing all this just to see the evaluation, like to check if the model converged, if the model is having less uh, loss, and also you're checking on some resources as well here to check if it's consuming or if we have enough resources for our training. Um, Once that is done, I think it might take a while to do that, or maybe it should probably complete that really fast. Um, and then comes once the training is done, you would do the inference. So there are two cycles here. Once the training cycle is done, then comes the inference where you are feeding the model with new questions and assessing the output. And you set all of these values, which is temperature, top heat, top K. You're just playing around with this knob on how your model could be choosing the tokens. Is it too diverse, or maybe uh, not highly diverse tokens? So just you're tweaking the model to be either being too creative or maybe to being more deterministic. So that those are some parameters that they have already defined that they have recommended already, and yeah, we can probably use that here to check. Um, okay, there is some issue. I don't know what was the issue. Okay, okay, there is a memory issue that is happening here. Maybe is it memory? Okay, I don't know if okay. Let's see if it's not training. Probably I'll just refresh that and yeah. Yeah, so yeah, this is what happened. It was running previously, but there was some issue with this. Uh, maybe I'll okay. I don't think this will be really that great, but I think I should have a different compute, maybe another one. Mm, but yeah, I think you could all just execute this and then check for the accuracy. I mean, I could resolve this issue now, but maybe I need to use a different output. But yeah, this is something which they already did. So you could check the output here. They are executing this against existing data and they're just doing the inference on that. So it's just predicting the next move. That's what it's doing. It's just like given incomplete different moves, then it is just checking for last move by these, where it is just looking for and spitting out those moves here. And then there you go. You once you're done with the fine tuning, you just save it and load the fine tune model. And and how and what is that you need? Um, what is that you need to fine tune this model? I'm sorry, I'm about to run out of my battery. So you need the low-res, right? So you got to train, you have to use this low-res to later on serve the model. So you're just saving this pre-trained loader model and then saving it to later on use to serve. And then for serving, there is something called VLLM that you probably could use all by yourself and hosted by yourself. So it's a great project. If you anyone wants to use VLLM, it's a project from Berkeley. They use paged attention to host models. So and it also supports LoRa and as I mentioned, the hard swapping of the LoRa's as well. Um, there you go. These are different, I mean, adapters. I mean, I'm sorry, I'm referring to a swapping thing, but yeah, it's called adapters, but you could swap different adapters to make the model behave differently. Um, so how to use that LoRa adapters with VLLM, because VLLM is the inference engine that's, I think it's in production everywhere, because if you're getting too many requests, there's continuous batching, there's paged attention. It takes care of model quantization. There's a lot of things VLLM does. Like if you guys, I mean, I might have a session on that pretty soon where we'll be going through VLLM. We do use that internally. We host a lot of models, our open source models using VLLM. So um, then you could use them and then they're using saving float 16 to VLL for VLLM, and then you're just using VLLM to serve it. And GGovs or even llama.cpp, these are all for CPU. If you want to serve this model on a CPU, you could probably use this conversion as well. So they're just doing different kind of conversions to do this. But yeah, I think this is overall, yeah, this is how a model fine tuning happens, and serving also happens here through this. So yeah, I just wanted to give a pause here because I know there are quite a few that we covered, and then take it from maybe take a few more questions or maybe any discussion that you guys want to do. We could do that as of now. So Andrew has a question. He raised his hand. Go ahead, Andrew.
Hi, can you hear me okay?
Yes, yes.
Okay. My question was going back to the data prep. That seems very important.
Yes.
So it seems like you were saying that you have to prepare like almost like question and response pairs in a way, and then you said you could use Langfuse to help with that. But could you go into one more level of detail about the data, the type of data you might use, and like how you would prepare that in terms of the format? So I'm not very familiar with that.
Yeah, so what is a skill that you want to teach your model, right? That's really important in your data. And also, when you're asking your model to do a specific thing, like maybe you want your model to reply, or even like in this case, it's trying to guess the next move. So your data itself should have a specific format, and the format should be in terms of the multi-turn conversations that we're going to have, just like how we're going to use ChatGPT, right? So that is something that we are using this data for, and the data itself looks. That's the reason why we use this ChatML template or get chat template. Is it's just a templatized version of this conversation where you have different personas. You have a system, a user, and an assistant. System defines the task. User is the input. Assistant is the expected output, because that is what your model should assume a persona to reply as an assistant, right? So you have these conversations put in this format, and then you're mapping the data set into this chat ML, and then you are just feeding it up here. So you see here, this is the task. Given an implicit set of chess moves and the game's final score, write the last missing chess move. This is the input format. This is the first task that we define, and this is the system message that you're gonna imply here. And then you have the user who gives an input, and the user input is this, where the user would just give it all of these different moves, and then the expected output is what you would get from an assistant. So you're just using this question and answers which are already solved, and then feeding that as the input to train your model.
Okay, that's helpful. So, and then one more question. So, follow-up question to that. So, you you have to define almost like this format, like you did. Like, can you go back up just a little bit more? You had like three pieces of it, right? Yeah. Okay. So you had the task, the input, and then the expected output. So when you prepare the raw data, does it has to be in that format, and or does then there was a data then there was a template, right? So my feeling was like does the template help you transform your raw data into the right format, or like what exactly is that template doing in that case?
So your template is basically, so this is the data set which is already available outside, right? It might be a publicly available data set.
Okay.
I should probably look at. I haven't looked at this, but maybe it's a data set that is already publicly available, is what I believe. Uh,
Okay.
it's the data set on Hugging Face, which has all of this data, and it might not always be in the similar format, but it looks like it is already. But I mean, they have a bit of change. There's giving a task, there's an input and an output, and you're just mapping that to in a chat format and then giving that as an input. Or maybe there's not doing much of data preparation here because it looks like data is already cleaned, and that's the reason why they're just mapping that to the chat, converting that into chat ML, and then these are multi-turn conversations, and then using that to to train the model. So yeah, I don't know if I
Okay.
answered the question.
So
Yeah.
my feeling there is just that obviously this is a template that somebody's already done the work on, but if we were to take on our own projects, I think the data preparation thing still seems a little bit like challenging. Like if you're not using somebody formatted data set that somebody's already cleaned and done all the work on, it seems to me like any of us doing our own projects would have to spend a lot of time to try to figure that data formatting out. Am I right?
I mean, that's something which there's a reason why I got LangFuse in place, because when you have proper observability for your existing chatbots, are you talking about if you already have a chatbot product, how are you making it more efficient? Because we are talking about SLMs, right? You're training an SLM with already existing data, and this data set is maybe in this case chat chess instruct model, but maybe in your case it might be a text to SQL problem, right? You're trying to solve a text to SQL in your enterprise, and you get this. Someone asks for a question, and you get a SQL, right?
Hmm.
Probably need to have your model. You might use that data set to fine tune, but your data set would be way different than this data set. So in your case, uh, how would you get that data, right? So how would you get that data is you create a chatbot to begin with, which might be using an LLM, maybe like ChatGPT. You have different questions the user ask, or maybe you just generate questions based on the columns that you have a database for. Like maybe your database has 5 different columns, and you just ask your LLM to create like 100 questions based on that. And now your LLM would get those questions and generate SQL. Get those questions, generate SQL. Now you have human evaluators who can evaluate. Maybe your BAs would evaluate and see if that query that is generated is right or wrong, right? And then you create this data set, which where these are all validated, these are right, maybe out of 100, 95 are right. And you use this data set to train your small language model. So now you're not no more using large language model. You started off with large language model, and large language model is the one which is generating these data sets. The output of this data sets is again used to train a small language model. So
Okay, that's a lot clearer now. Thank you so
yes,
much. I
yes,
was missing that whole piece of it. So thank you.
yes, yes. I mean, that's the reason why I've jumped into LangFuse, because the reason why I put LangFuse there is because you need observability to begin with, and that again, when you have that, you could create data sets. You can tap into that data. That would be valuable data for you to later on, have your SLM trained on. And as I said, SLMs to begin with, they're not great because they're not specialized in certain skill. But you're using a teacher model, like maybe these large language models who already has this, huge skill of writing great SQL. You're just, tapping into that cognition power, and now you're just training your small language model, and eventually you're beating that large language model, right? So and you're also fine-tuning that in your own domain. So then your model learns what different columns are and everything. But yeah, maybe as I said previously, I also gave an example. Don't never use that. Never ask an LLM or even an SLM to generate SQL. All they have to do is a function calling rather than generating SQL. But it could be any other data set. It could be maybe answering questions about your policies, your HR data, whatever it is, or maybe an agentic that is going and doing an API call to alert users if something happens, right? In that case, your basically your data would be tool call. So it's a tool call data set. So tool call is um, So I'll tell you, that's very interesting, by the way, because in that case, when you want to fine tune using maybe reinforcement learning, so what you do is if your agent is trying to go ahead and do a booking and you want to fine tune, if you want to improve the accuracy of your agent to do a booking, right? Booking does require research. It requires, fine tuning or even adding filters for your use case. It requires getting information about your personal choices and then applying it to that and then going ahead and doing the booking. So booking is the last step, but these are all series of steps that it has to do to achieve that. So they create an artificial environment. They create a database, which is, just a simple database with SQL. And they have this AI agent that can go ahead and do this task. But AI agent might not always end up doing the booking, right? Because how does it do a booking, right? You could just go and change the state of your database. So if you know the database state change, it means that agent did its job. And that way you can collect or you can see the agent behavior, whether it was able to solve the problem, and then use that data, the stream of actions that it took to, to do the booking, and use that to train different SLMs to perform similar kind of actions and make and get better. And reinforcement learning will be a great addition here because now reinforcement learning can actually, because now you have a verifiable output. So there's something called reinforcement learning with verifiable rewards or verifiable outputs. Then you could scale it up and make your small language model do way better than LLM. That's the reason why NVIDIA says it's the future of agentic AI. So SLMs are the future of agentic AI because the cost is low. Your SLMs are domain trained. You own the model, right? You're not just outsourcing or maybe getting from ChatGPT. Who knows? They might be sniffing on your data, but I can comment on that. But yeah, so I think that would be a good use case and a great question. Yeah, thank you. Any other questions anyone has? Okay, yeah, Uma did ask a great question. How do you understand you are overfitting versus generalizing? So overfitting is definitely a metric. It's a overfitting means memorization. By assessing the your loss a curve, all of this loss curve, you can definitely see if your model is overfitting or not. If it is flattening out, there's not much gains, then you're overfitting, right? Generalizing, you give new examples based on your data set. You're just not getting a pure conversions, but or no, it's actually really smooth. There's nothing flattening it out. Then yeah, it's just generalizing. But we are not training SLMs from scratch, so we don't even need to go in that route, right? We're not developing these. We're not training an SLM or an LLM here to see the loss function and see if it is going down or high. What we're doing here is to imbibe certain skills within these models, so that would end of the day would define how much data that you have given, and it is not a one-time thing. So even if it was able to solve 199 questions out of 100, maybe the next iteration it might only solve like 5 questions. So end of the day, you again need to in that case, you again check for like overfitting, and you create new data set which is completely new, or maybe you just expose that to the users and now you go and analyze the output. If it was just not able to give you the exact output how the users is desiring, then yeah, maybe you can't. Then you definitely know it's overfitting or it's memorized some of your instructions. So there different prompting is also a fine tuning. It is a way to fine tune your model, but prompting would not always give you accurate results. You could, and prompting SLM, you might burn its context length as well. So you should probably need to be a bit careful about that. Yeah. So maybe in your case, so yeah, what are the evals to consider here? So first thing is your evals are directly they directly depend on the task at hand. So what is the task that you have at hand? Is your task as deciding if the LLM, if the writing is good, or maybe your task is to design if your agent was able to do a specific task? So what is your task is at hand? Based on that, you give your own scoring, and then you can either use LLM as a judge or use your own human itself in the loop to decide if that output is right or wrong. If you want to scale up on that, LLM as judge is great because you're using again an LLM to check, or maybe a self-verifiable check, right? When I gave an example of whether the booking went through or not, whether agent was able to successfully do a booking or not, is to just go and check the database state. If the database state changed, it means that it was doing successfully doing the booking. Just not the database change. You should also look for like other actions that it performed before that, right? Research it did research or not. You again need to check for that. So you have this series of actions that has to do a booking. So you keep a you log all of those actions and then and then create your own evals based on that. Scoring. These are all personal to the domain task that you're solving. It's not like a traditional ML engineering where you're checking for like overfitting and all of those. You definitely can play around with like temperatures and all of those to check to see if the model behavior changed a bit. But also it all depends on like what is your task at hand. End of the day, that would only make your system more efficient. Is what is a task at hand. If you're looking for creative writing and things like that, maybe you can use LLMs itself to judge that output. If you're using coding or math, the data itself can act as verification. So yeah, that all. Um, Oh, no, very large verifiable results. No, we just need few examples, and people are able to align the model for using reinforcement learning with verifiable rewards. They were able to do that with like very few models, like very few examples, maybe 1,000 examples they're using to converge because reinforcement learning is doing wonders now with verifiable rewards. But as I said, it has to be a verifiable reward. Yeah, and and again, to verify again, you're using AI. So what if AI itself is really not giving you the best output? But yeah, with reinforcement learning, I think task like going out and checking, doing bookings, all of this, and reasoning is a great use case where reinforcement learning can definitely give a lot of benefits, where you can have this reasoning power imbibed into a small language model. But yeah, great questions, Uma. I do see that. Yeah, I mean, do you come from a traditional machine learning engineering background? Looks like. Are the
Yeah, right.
Yes, yes, yes. Based on your questions, I get it. Yeah, but this is a bit different than traditional machine learning because traditional machine learning, you're dealing with structured data, whereas here you're dealing with unstructured data. So yeah, the way you measure and things are a bit different when compared with the traditional machine learning workflows. We will be posting the recording. So I'm doing a live stream of this. So you probably see this like in YouTube too. I would also post this on on our maybe on our yeah, other streams, other channels too. But yeah, since it is live streamed, you can probably check it on on LinkedIn. You can check it on YouTube and all of those different platforms. Um, I don't know how the stream is going because the first time I'm doing this, I do know there's a lot of folks in there might be. Um, oh yeah, it's still going on. Yeah, I just went through the streaming. So yeah, in YouTube, you could see that in. Let me share the channel where we have this YouTube stream going on now, and also you will have this slides being posted in our meetup group. Um, and there's also a LinkedIn page. So we are coming up with new platform called Agentversity. So it's for someone who want to learn. If you're coming from traditional machine learning background, if you're coming from I'm sorry, software engineering background, and if you're coming from like any tools that you have previously worked on, so all of those, I think you can use you can use this platform to learn. So it's called Agentversity, and we're building we're building this platform agent native. So you'll have AI agents and trainers to who can help you to learn and get into generative AI. So it's more of like you can say a tech platform. I'm sharing that here as well. We are launching pretty soon, probably in the next few weeks, will be live. If we're coming up with very good use cases, one size fits all. That's all. Most of the things are outside. Like now, you have one size fits all. So just have one curriculum, and everyone will be going to the same curriculum. So that is a problem that we're trying to solve. We don't want to do that. We want to make it hyper personalized. We do have a backbone structure alongside your own stream of courses or curriculum that we will design for you per person. So it's not, we have this course and you go through the same thing. No. um, and we are a huge cloud and DevOps shop. We have a lot of engineers who support us, so we are building labs too, on-demand labs as well. But it's still going on that work. Maybe we might come with labs in the next cohort. But at least in this cohort, we might come up with some platform level features that everyone would go through and learn this. So let me share this page. We are, as of now, we're just posting some news and all of those as here. But pretty soon we're gonna do live news. I'm sorry, live sessions, or even more of these uh, uh, one-on-one sessions, or daily updates sessions, paper reading sessions. All of these we're planning in the coming weeks, so that we are just out there and illustrating and explaining stuff for anyone who want to get into AI. Like, we want to be closer to you guys and build this community more. So yeah, our community is growing a lot now. I think there are a lot of people joined from Charlotte, Toronto, and New Jersey. So there are three different places where people are joining in from. So we built community to understand the issues and then build a platform, because community is where we get all the feedback from. Um, yeah. So I'm just putting that here, right here. Sure. I don't know. I should have got the right link, but yeah, this is where you can also see the live stream. I'm also posting that the LinkedIn here pretty soon. I'm sorry, my LinkedIn here. If please do follow me. I mean, I'm not a AI influencer. I'm just like, sometimes I post things which I feel like are something which I'm really excited about. So yeah, please do follow me. If I don't connect, please don't be offended, because sometimes I don't connect because because my LinkedIn is all like news about new AI stuff. Sometimes your interest would be something different, right? So I don't want that conflict. That's the reason why I asked anyone to follow me, and then we can all uh, just exchange and and work on maybe different projects. I'm also thinking about having like a hackathon pretty soon, where all of our community members can just sit and hack through some projects, cool projects. Yeah. So anyone already working with AI agents, anyone doing fine tuning, I'm really interested in learning and listening from you guys. Anyone who's already here and maybe did all of these in your actual enterprise environment, please go ahead and share that if possible. If not, so no one is doing Gen AI as well as of now. Oh, Veda Vyas. Yeah, go ahead, Veda Vyas.
Hey Raj.
You. Yeah, good to see you back. Yeah, I mean,
Yeah,
we're building
so
a medtech medical,
exactly. Yeah,
yeah,
you
medical
know,
tech startup, and there are a lot of things. I mean, this is really exciting to see Gemma. Sorry, what three? What this world where you have a picture and you get into Genie 3, right? Genie 3.
right.
I think yeah, it's from Google. I feel like that might be a great use case in your case as well,
Right.
right? Yeah. Go ahead.
So we're trying to fine tune med palms one. We're trying to get the access.
Awesome.
So that would be something that we're looking at, and we're also trying to get the DAX Copilot. So we're trying to find, we will have like multiple small language models, and we'll have a agentic system where we can also assist medical students and doctors and the same time. So we're trying to
Okay.
build a medical platform. So we just pivoted a little bit from the last time that we had a conversation. So it's going good
Well,
now.
that's great. Yeah. I mean, I just want to share you that paper. It's also a
Sure.
medical reasoning paper. They have this medical really domain tuned. These small language models are already they're only trained on medical data because medical data is very different. They have chemical
Exactly. Yeah.
position, they have multimodal data. That's a tricky part, right? When you're dealing with multimodal data, your RAG or you're not dealing with pure text data. So multimodality is definitely a great use case for you guys. Like you guys can use that. Um, Polygemma is also a great thing.
Right.
Uh, oh yeah, I think Mahesh, you are also from the life science domain, but I didn't get a chance to work on agents. Oh, that's fine. So when you say you worked on Gen AI, so what is that you did, Mahesh?
It's
With the
just
domain.
plain LLMs and the RAG structure and the
Okay.
pydantic and those things. Yeah.
Okay, so you did RAG, and what kind of RAG are you using? I
It's
mean, your
just
data is it
naive
pre-processed,
RAG and
getting
adaptive RAG.
prosecutors? Sorry?
Naive and adaptive RAGs.
Oh, yeah,
Yeah.
adaptive RAGs. You did.
Yeah.
Okay, okay,
Yeah.
awesome. I mean, you could still use agentic RAG. I mean, agentic RAG is just like, you're just doing uh,
Mhm.
again, a iteration on the retrieval part and doing like multi-step, multi-hop, question and answering to just know if what you retrieved is right or wrong, right?
Yeah.
That's there. So it's just a text space where you're doing it in a text or is it multimodal model?
No, it's a text based.
Text model. Okay.
Yeah, text
Yeah.
model.
Yeah. Um, oh, thank you. Uh, okay. Yeah, sounds good. Nemo LLM. I get your point. The SLMs are better for non-representative tasks, but the point of AI is any task. Okay. Nemo LLM guardrails. Okay. Nemo is actually from NVIDIA, right? Vedavyas?
That's right. That's right.
Yeah,
Nima is from
it's
NVIDIA.
LLM guardrails. Okay, they have different guardrails in LLMs and all. Okay, cool. I mean, I'm thinking to do some cloud-based thing because I see a lot of people really love to do some AI stuff on cloud, and they also want to learn cloud alongside that. So maybe we'll be using like AWS or Azure. We already did AWS Bedrock. We got a huge turnout. I mean, it was 800 RSVPs across different groups. So maybe we want to do something similar again, maybe around Azure and GCP this time, and try to see how their agents or Gen AI services have came along as well. So what's the difference between using a low parameter model at full precision versus a larger quantized model? I mean, low parameter model, full precision, larger. When you say larger is it apples to apples comparison? Is it low parameter full precision and a low parameter quantized, or is just low parameter model at full precision but a larger quantized model, right, Arthur? If if I want to answer your question, I one thing is definitely always larger models perform way better when you compare with a smaller model. Even if you have low parameter model with full precision, right? Oh yeah, like wait, oh, so always 16-bit. Okay, you also have a larger and a quantized model. Okay, that's oh yeah. Even in that case, the 16 GB parameter model would probably like be way better when you compare with 270 million. Come on, 270 million. I don't even think even Google says like 270 million is not used for building agents or anything. Probably they are mainly giving emphasis on instruction following. So that's the major use case, but 16 billion parameter model, 4-bit quantized, yeah, that can do wonders when compared with 270 million full float models, like full float, because even if it's full float, it's just 270. I mean, also one more thing is 270 or the quantized full precision or even quantized model, the accuracy depletion is just not that drastic. It's just few points, maybe like 1 or 2 points, your accuracy is lower, right? But the gains are higher because when you're running 4-bit quantized model, you're just not spending too much of compute. And when you quantized it, the accuracy drop would probably be like -2 or like -3%. That's it. you may not able to run a low precision parameter model full. We could run, I mean, but it all depends on the hardware for sure, DJ. I mean, yeah, but we can run it. Okay, large K models can run on lesser hardware. Yes, yes, they can run. But yeah. Okay, yeah, sounds good. But yeah, I think 270 million and 16 GB comparison to 16 billion parameter quantized comparison, I think even just removing quantization in picture, just 270 million and billion itself makes a lot of difference. Um, yes, yes, absolutely. Quantization is just to do the inference performance. The size definitely makes sense because more parameters, more patterns it can grab, and the better will be the performance when compared with a regular 270 million parameter model. Yeah, you cannot run them on certain hardware, that's for sure. But yeah, um, it all depends on CUDA kernel and your hardware that you're using, the GPUs that you're using. But yeah, but when you're saying the size is still the main factor, yeah, size ultimately is the main factor. Quantization is more of inference performance and also edge deployment. Let's say if you want to deploy that on a phone or maybe a small device at home, you could do a quantized version of it because you're not really worried too much about like 1 or 2 points accuracy drop when compared with the joy of running it locally on your machine rather than paying some cloud provider the money, right? So yeah, definitely edge deployment is a huge deployment. Inferencing is where the quantization will shine, and also training or fine tuning also quantization shine because when you quantize. When you fine tune with quantization, possibly you're not consuming a lot of compute there. Yeah, hopefully I answered your question, Arthur. Yeah. So we only have 3 more minutes left. If anyone has any more questions, please do feel free to ask now, or we can drop from this call. But I enjoyed this conversation. There's a lot of folks who uh, ask great questions, and also I think small language models are definitely evolving way faster than, and I feel like that's a great future ahead because when you have a small language model that is sitting in your phone, talking to someone who is not doing great, maybe emotionally, they want to share with someone without any risk of ever future data loss. Or even as people giving more tool access to this AI, we're not even worried about it. So having it in air-gapped environment and sitting in a uh, uh, home is great. 270 million param. People are saying you can even deploy that in on your toaster, right? So many use cases that you can solve with 270 million parameter model. If you can fine tune it, maybe a fine tune version would probably give you a different quote every day based on your mood. Deploy that on probably a simple attach a speaker to a simple Jetson Nano, or not even a Nano, maybe an Android small Zebra device could hold this and 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 tell you jokes maybe every single day, different joke every day, right? So yeah, there are different use cases that you can solve. Or maybe just doing some tool call, maybe doing analysis of different weather movement and everything, and going ahead and turning off maybe your shutters, or maybe opening, or maybe turning on your irrigation or turning off your irrigation. So these are some, even though there's IoT element, but the beauty of dealing with this large language models is, or even the small language models is their cognition. They are really they can sustain any interruptions from the regular formatting, right? Rule based automation is something that cannot tolerate a simple change in a rule, would probably break that automation. But LLMs or even SLMs could be more lenient in that sense. So edge would probably play a great role here. Function calling, tool calling would play a great role here. Oh yeah, Agent University link, I think I have already put here. Um, let me. I'm not able to get the exact link for, but it's on LinkedIn right here. We have a website too, and we're on Twitter. There are quite a lot which are there here. And whatever these meetups are all part of Asian University. These meetup groups, everything is part of the main meetup Asian University organization. So even if you need any information, please do ping even on our meetup channel too. So that should be a big deal. Okay, thanks a lot, everyone. Have a great evening. Thanks a lot. I think I enjoyed this conversation. We'll probably have